All right, so ever thought of the periodic table as like a giant city? Because that's what we're doing today. The columns or groups are basically different neighborhoods, and each one has its own, well, family living there. We're about to take a little tour of three really distinct blocks and meet three very, very different families.
And this is where it gets really interesting. Because in this chemical city, you've got your social butterflies, your aggressive types, and then your total loners. So the big question is, why? Why are some elements foundational, always building things, while others are super aggressive, and then you have this other group that just wants to be left alone? What's the secret behind these personalities? Well, the answer, as you're about to see, is actually pretty simple and kind of beautiful. Okay, so let's meet the families. First up in Group 16, we've got the builders. These guys are foundational, absolutely essential. They literally formed the crust of our world. Then you've got their neighbors in Group 17, the reactors. Think of them as the highly energetic, super reactive ones. They're always looking to make a connection. And finally, rounding out our tour are the aristocrats in Group 18. They're aloof, totally self-satisfied, and they really rarely interact with anyone.
So, how do we start to unpack all this? Well, a great place to start is with their names. Seriously, an element's name can tell you a whole lot about its personality and what it does. Let's start with our builders in Group 16. Their official name is the Chalcogens. It's a Greek word that means ore forming, and wow, is that name perfect. These are the elements that build key minerals. And get this, the head of the family, oxygen, makes up almost half, 46.6% of the entire Earth's crust. Just incredible. Okay, moving on to the reactors in Group 17. These are the halogens, which means salt-producing, and this name hints at their aggressive nature. They're so reactive, so eager to make a connection that you literally never find them alone in nature. They're always bonded to something else, forming salts like, the table salt in our oceans. And that brings us to Group 18, our aristocrats, the noble gases. Their name says it all, right? They're noble because they're chemically inert. They're above it all. They just don't interact. They're perfectly content to be alone, mostly just hanging out as pure gases in the atmosphere. So, we've got the builders, the reactors, and the aristocrats. But what's the real secret? What's the one thing that drives all this different behavior? Well, it all boils down to one simple thing: electrons. Or, more specifically, the quest for the perfect number of electrons. Right, and this, right here, this is the key. The secret to each family's personality is written right here, in their outermost electron shell. This is the blueprint. Everything you need to know about why they act the way they do, it's all in the numbers. Okay, let's look at the builders, Group 16. They have 6 electrons in that outer shell. Now, the magic number, the goal for every element, is 8, so they're 2 electrons short. That's their whole motivation. That need for 2 more electrons is what drives them to build all those essential minerals and ores. Now, check out the reactors in Group 17. They have 7 outer electrons. They are so close to that perfect 8, just 1 electron away. Can you imagine? That's why they're so aggressive and reactive. They're on the verge of stability, and they will do almost anything, grab an electron from basically anyone to get there. And then the aristocrats, Group 18. They have 8 valence electrons. They've got the full set. For them, the game is already over. They've won. Their outer shell is perfectly stable, totally complete. So why would they bother reacting with anyone? They have absolutely no reason to. They're already perfect. But here's a fun twist. Just like in any family, you've got your rebels, right? The ones who don't quite follow the family rules. In the periodic table, it's often the very first element in a group that breaks the mold. And understanding these rebels, well, that's where things get really interesting. Let's take oxygen, for example, the head of the builder family. It is such an outlier. The rest of its family members, like sulfur, are solids. Oxygen, it's a gas. It also has this incredible ability to form these super strong hydrogen bonds, which, by the way, is essential for life itself. And while its siblings can be a bit more flexible, oxygen pretty much just sticks to one oxidation state, -2. So what's the deal with oxygen? Why is it so different? It's really a combination of 3 key things. 1, it's tiny. 2, it's super electronegative, so it's amazing at pulling in electrons. And 3, and this is a big one, it doesn't have any d orbitals. That means it can't do this little trick its bigger siblings can, where they expand their electron shell to make more bonds. Now let's pop over to the reactor family and look at their rebel, fluorine.
If the halogens are an extreme family, fluorine is the most extreme member. It is the most electronegative element, period. Full stop. And just like oxygen, it's pretty much locked into a single oxidation state. What's really wild is that its own bond with itself is surprisingly weak, which is part of what makes it so incredibly reactive.
And if you look at why fluorine is so different, hey, does that sound familiar? It's the exact same story as oxygen. It's super small, it's the most electronegative, and it has no d orbitals. This isn't a coincidence. This pattern, the first element in a group being the weird one for these exact reasons, is something you see again and again.
And here is a perfect example of why this all matters in the real world. Just look at these boiling points. See the trend? They go up as you go down the group. Except for water. H2O is just wildly off the chart. It's way, way higher than it should be. Why? That's oxygen's rebellious hydrogen bonding. Without that one weird property, water would be a gas on Earth, and life as we know it just wouldn't be possible.
All right, so we've met the families, we've uncovered their electron secrets, we've even seen the family rebels. Let's wrap things up and put them all side by side for one final comparison.
And this table really just sums it all up, doesn't it? The builders need 2 electrons. The reactors are desperate for 1. The aristocrats need none. That simple fact, their electron need, is the root cause of everything else. Their reactivity, what they look like, what they do, it all flows from that one single elegant role. It's just a beautiful system.
So there you have it. An element's personality is literally written in its electrons. We've just peeked into the lives of 3 families today. But, every single column on that periodic table has its own unique story, its own dramas, its own rebels. It really makes you wonder, what other stories are just sitting there waiting to be told right across the rest of the table?